When two atoms bond, where do the electrons really live? Are they trapped between atoms or spread across the entire molecule? In many molecules, electrons don't belong to just one atom. Instead, they're shared across the entire molecule. In this video, you'll learn what molecular orbital theory is, how atomic orbitals combine, and how that leads to bonding and antibonding orbitals. Molecular orbital theory says electrons are spread across the whole molecule, not locked between just two atoms. These orbitals form when atomic orbitals combine using a method called linear combination of atomic orbitals, or LCAO for short. Because electrons behave like waves, combining orbitals can either reinforce each other, called constructive interference, or cancel out, known as destructive interference. When orbitals combine in phase, their waves reinforce each other. The electron density increases between the nuclei, forming a lower energy bonding orbital called sigma by constructive interference. When orbitals combine out of phase, their waves cancel out. A node forms between the nuclei, creating a higher energy anti-bonding orbital called sigma star. An energy diagram shows that when atomic orbitals combine, a bonding orbital forms at lower energy, while an antibonding orbital forms at higher energy. Electrons always fill the lowest energy orbitals first, which is why stable bonds place electrons in bonding sigma orbitals. So far, we've seen how atomic orbitals combine into molecular orbitals, and how bonding and antibonding orbitals differ. Ready to lock it in? Tap the link for study guides and flashcards on this topic, so you can keep learning without missing a beat. Up to now, we've focused on s orbitals, but p orbitals behave a little differently. Each one has two lobes with opposite phases, and that changes how they combine. When p orbitals overlap end to end, they form sigma orbitals. When they overlap side by side, they form pi orbitals. Just like before, phase matters. In-phase overlap produces a pi bonding orbital, while out-of-phase overlap produces a pi antibonding orbital with a node between the nuclei. A common mistake is assuming electrons always fill both orbitals. In the ground state, antibonding orbitals remain empty unless forced by higher energy. This is why molecular orbital theory matters, especially for complex molecules. In these cases, electron density is shared across many atoms, not just one bond. To sum it up, atomic orbitals combine to form bonding and antibonding molecular orbitals, and where electrons end up determines whether a molecule is stable. Now that you've watched the video, let's see how much you remember. Head to the link in the description, where you'll find Quizlet content made just for you.